NASA sent a spacecraft toward an asteroid named Bennu with the goal of collecting samples from the space rock without actually landing on it. In 2020, that sample collection happened, quite dramatically, I might add. And in just a few days, the spacecraft is returning to Earth, sample in hand. And so we're very excited about the OSIRIS-REx mission. And today we have NASA expert Noah Petro here with us to discuss the ins and outs of the mission and what this endeavor might mean for the future of space studies. Thank you for joining us, Noah.
Oh, my pleasure. Thank you for having me. What an exciting time.
Oh, of course. And so to begin, I guess the question everyone has is, we've collected moon rocks and we're looking at Mars sample return. Well, what can we learn from asteroid sample collection that we can't with planetary or moon samples?
Well, the first thing is really that we think that asteroids reflect the very earliest parts of our solar system's history, that they are effectively pristine fragments left over from maybe the first few 100 million years of solar system evolution. And as such, as they hurtle through space, remain relatively unchanged. And so what we hope to learn through the samples from Bennu is what this particular type of asteroid, this carbon-rich asteroid, how it reflects what happened 4.5 billion years ago, and compare it to what we learned from samples from Apollo, through other meteorite and asteroid sample studies, and really, again, use this to inform how we construct the family tree that is our solar system, and maybe challenge some assumptions that we've had, change our interpretations of early solar system history, and then guide us on future studies of our solar system.
Yeah, absolutely. And more specifically, why was Bennu selected as the asteroid for this project? And I guess in particular, why was the northern crater from which the sample was collected, why was that the site?
So for multiple reasons, Bennu was an excellent target. One, it's a near Earth asteroid. It will pass close to the Earth in the future. So we want to understand what these potentially future Earth intercepting asteroids are like. And so by going and studying it, orbiting and mapping the asteroid, we get a greater insight into the properties of this wonderful rock in space. Collecting the samples, again, these carbon-rich samples may inform our understanding of what were the things that seeded Earth with the chemistry that led to life. There's a possibility that we'll find amino acids, chemistries within these rock fragments that may have helped introduce the compounds that lead to multicellular life on the Earth. The other thing is again understanding how these samples relate to fragments from other asteroids that have been brought back by the Japanese Space Agency, from meteorites. For me, one of the exciting things is by shepherding these materials through the Earth's atmosphere in the sample return container, we're able to understand how different pristine samples are from those meteorites that we've been studying for well over 50 years. And so the sort of the encapsulation and preservation of those fragments from the surface of Bennu will help us understand meteorite history, whether it's from Bennu or other objects that reside in our labs. Now, the interesting thing about the spot that these samples were collected from goes back to our interpretations of the Earth-based data that we had of Bennu before OSIRIS-REx was launched. It was assumed that the surface of Bennu would be relatively beach-like, very fine-grained material covering the entire surface. Of course, when we get there, we see that the surface of Bennu is covered in rocks. Almost every inch of the surface has a rock fragment. I'm holding a small piece from my personal collection of a rock fragment. The entire surface was covered in these rocks. And so the spot that we ended up collecting these samples from was one of the few places that was not completely covered by rocks. And so the fascinating thing will be understanding what we got and how the samples we collected relate to other parts of the asteroid. And again, we have this wonderful collection of data from the orbital phase of the mission, understanding what we have compared to what we think exists elsewhere on the asteroid is going to be, I think, a very exciting field of study as we unlock these samples.
Yeah, absolutely. One of the most interesting things about the sample collection to me was when the spacecraft reached out and it went sort of poof instead of having like a solid surface as we might expect with an asteroid. Was there any reason that the team decided to not land and actually just do a touch and go?
Yeah, I mean, the idea to do touch and go was baked into the mission from its very earliest stages, because to actually stop the spacecraft and touch for more than a few seconds takes fuel and time. So this idea that we touch and go to make it this cosmic kiss really simplifies things. You know, as we touch the spacecraft, there's a blast of gas to kick up material that
Mhm.
then gets collected into the sample collection system, and we leave. You know, the assumption was, and again, remember, Bennu is a very small object, so it's a microgravity environment. So there was a thought that when we touched the surface of Bennu, that it would kick up abundant dust, that it could become this dust cloud around the spacecraft. So we wanted to get the spacecraft away from this dust cloud as quickly as possible. So through this touch and go, we minimize the chance for contaminating the entire spacecraft, but maximize the opportunity for collecting these precious fragments that will be returning to Earth on Sunday.
Yeah, absolutely. And one of the things that I was really awestruck by is reading about how, like, what it took, like the maneuvers it took to bring this spacecraft not just back to Earth, but to a very specific spot in Utah. So, what does
Yep.
it take to accomplish such a feat?
It takes practice, high level math, engineering, but also an understanding of exactly where the spacecraft is in the solar system, right? So this is one of the wonderful things about tracking spacecraft is we know where OSIRIS-REx is within a few meters of its location as it hurtles towards the Earth. And it will drop off the sample return canister. And that sample return canister has to find a particular spot above the Earth. Parachutes have to deploy, and it will gently touch down in the Utah desert. This takes, you know, a team of people. I hope people don't think that, you know, missions are one or two folks locked in an office somewhere crunching numbers. This takes expertise across NASA and really around the world. This is a global effort to return these fragments to us here on Earth. And you know, we've had an opportunity to do this type of thing before. There was the Genesis sample return mission from many decades ago that was effectively a test run for this. So as much as everything is new with OSIRIS-REx, we've learned from previous missions how to do this. So we have great confidence that, you know, come Sunday morning, we'll all be glued to our televisions and see parachutes deploy and a gently rocking spacecraft touch down in the Utah desert and make its way to the Johnson Space Center, where those samples can be curated so that not only scientists today, but scientists for decades and centuries to come can benefit from the samples that come back from asteroid Bennu.
I'm certainly very excited. And I know the whole space.com team is. We've been covering it very detailedly. I don't know if that's a word. Um,
It is today.
It is today. On something you said about how these samples will be used for generations to come or studied for generations to come, I was really impressed by one of the points in the mission overview, which said that 70% of the sample is going to be preserved at, I believe, Johnson Space Center.
That's right.
And I wrote the quote down because I really loved it. It was for a study by scientists not yet born using technologies not yet invented. So, what do you think is the importance of that approach? And if you can think of any, what are some gaps that we currently have in these studies that like future technologies can help fill?
The valuable lesson comes from Apollo samples, because we learned in 2008 that by studying previously studied samples, we could find water in them because we had instrumentation that could measure smaller fragments. And so the valuable thing for OSIRIS-REx is to preserve everything from fragments the size of a walnut down to things that are microscopic, because future studies of those microscopic samples will find things that we miss in the next years to come. So the study of smaller and smaller fragments, I think, is where the bonanza will be, because we expect that there's going to be many microscopic samples that we'll have. And so, you know, my children and their children and their children's children will develop those technologies and unlock the secrets that are held in those tiniest of fragments.
Absolutely. And just the second part of my question was sort of, what are there any gaps that we currently have when studying these types of samples that you know of that you hope will be filled with future technologies?
You know, I don't know. I mean, that's the joy, is that I think that the questions that we want to ask haven't even been raised yet, right? So for me, it's perhaps about what might have, you know, where in the solar system did those fragments form, and so extracting every piece of atomic information from them using technologies that have not yet been developed to answer questions that actually might get raised by other sample return missions. We're going to be surprised by Artemis. We're going to be surprised by bringing in fragments from across the solar system, and so those missions will help inform things that we ask of OSIRIS-REx, and we know that we'll be surprised. And so for me, the joy is finding out where the surprises come from that lead to future questions.
Definitely. I guess sort of related. I think a lot of the time the public questions whether it's worth funneling money into space missions in general, and more specifically very science forward space missions like OSIRIS-REx. What would you say in response to that? Why is this important for humanity?
Yeah, again, I think it becomes again the fodder for future science. And in my limited amount of time that I have left, I want to say we've learned that missions not only fulfill science questions today, but then allow us to raise and answer other questions. We have data from Bennu, we have the samples, and those are going to be used for decades to come, centuries to come. And so yes, it takes money, but those fund scientists to ask important questions, to educate the public, and then hopefully inform people and excite people to become the future scientists. I'm hoping that the kids that watch the sample come back on Sunday will be those future researchers who are in laboratories around the globe studying those fragments and unlocking the history of the solar system.
Wonderful. I know you have to leave soon, but I guess I'll just leave you with one final question. On a very personal, like in your opinion, what would be the best thing we find from these samples, and what would be the worst, do you think?
I mean, I think that the best thing that we'll find are fragments potentially of water, of amino acids that may have been the precursors to seeding life here on the planet, as well as the ages of these samples. How old are they? Are they 4.8 billion years old? Are they 4.4 billion years old? Are they 3.8 billion years old? Bennu will hold secrets. Some of them will surprise us, and that's what I'm most excited about. I think the worst case scenario is that we get a suitcase and all of the rocks are very similar. I'm looking for the diversity of fragments as well, because we know that there are different types of material on Bennu, and I expect that these samples will all reflect the diversity of that asteroid and have other surprises as well, other fragments of other asteroids that have found their way onto the surface. But even said, if everything is identical, we will then have material that is the feedstock for future scientists and for understanding this earliest history of the solar system.
Wonderful. Thank you so much for your time, Noah. This was really insightful, and I really enjoyed our conversation.
My pleasure. Anytime, and enjoy the show on Sunday.